Okay, the first example of a titration, acid-base titration we're going to look at is a strong acid, strong base. So let's imagine we have a we're going to use HCl as our titrant, and our analyte is going to be sodium hydroxide. So strong acid and strong base. And as with any titration, we want to identify what's the reaction happening here. So if we have a strong acid, strong base, our strong acid is going to dissociate completely into H plus Cl minus. Our strong base is going to completely dissociate as well into sodium hydroxide. And we can see that this is just going to be an acid-base neutralization reaction. So we'll form water, and these ions are just spectators. So our net ionic equation is just that we have H plus OH minus reacting to form H2O. Now for titration, we want this to have a very large K value. And so this is the opposite of Kw. So we can say the equilibrium constant here is 1 over Kw, which is going to be 10 to the positive 14. So this is a very favored reaction. So it has a very large K value, very fast reaction. So this matches everything that we need to do an do a titration. And this is going to go to completion. Okay, so we don't need to worry about Ka or Kb for these species because they're strong. They're strong acid, strong base. That's by definition, we don't need to worry about that. Okay, so but let's look at the different parts of the titration curve and what it's going to look like. Okay, so we'll look at the specific case where we have 0.1 molar HCl and 50 milliliters of 0.02 molar sodium hydroxide. Okay, so the first point that we're going to think about is before any HCl is added. So what's the pH of the solution there? Well, that's pretty straightforward because we know that the concentration of hydroxide is equal to 0.02 molar. And from there we can find the pH pretty straightforwardly. All right, so we can find that the concentration of H plus is equal to Kw over concentration of hydroxide. This is just a rearrangement of the Kw expression. And if we plug in the values there, we'll get 5 times 10 to the minus 13, a very small number as we'd expect because this is a very basic solution. It's a solution of strong base. And that gives a pH of 12.30. So that's our starting point. As we add acid, that pH is going to decrease, of course, but slowly at first, and then at the equivalence point, we'll have a drastic change in pH. Just like when with precipitation titrations, we had a drastic change in the PAG or whatever else we were using as our titrant. That concentration changes rapidly. And that's what allows us to observe the endpoint of our titration. So in the next video, we'll start looking at adding acid to our titration.